For this one, I did F3-11. It's a problem that it's a 3D tension problem with 150-pound weight hanging off of it. The first step to this problem is to draw the free body diagrams, and I just used the picture on here to do that. So I have TC going this way, TB going this way, TD going this way, and TE going this way. And so the first step is to put the forces into Cartesian coordinates. And so basically all that means is you look at the picture and you say, okay, for TB, this is the x-axis right here, this is the y-axis, and this is the z-axis. And so how do we get from here to here? So first I look at the x-axis. So we go this way, so that's negative, and we look at this number right here, that tells us the distance here. So we go -6, so that's the first value. Next we look at the y direction. This is the y-axis, and this is positive from where A is positive. And so we look right here, we see that we go 3 feet from here to there. And so we have +3 for that. And then last one on this one, we look at the z-axis and we see right here A is at 0 on the z-axis, and we go up 2 to get to B. So we have -6, 3, and 2, and we multiply that by TB. And so the bottom, the denominator, is going to be the magnitude of that vector. And so we have the square root of 6 squared plus 3 squared plus 2 squared, and we get that from this. And so that's our first vector. Our second one is TC, so we do the same thing. It's in a similar area, but we look at the x direction. We still go back 6 feet in the same spot, so it's going to be in the negative direction. So the first value is going to be -6. Then we look at the y-axis. This time we're going negative direction 2 feet right here. So it's going to be -2 is our value, and then we look right here and we go up 3 feet in the z direction. So we have -6, -6, -2, and -3. And then we do the same thing for the magnitude. This is just going to be the values that you get from here. And then you multiply it by TC this time. For TD, this only goes in one direction. So the only value we have is going to be TD. And that's because this is going to be 1. And 1 multiplied by TD is just going to be TD. And so that's where you get the TD 0, 0, because there's nothing else in these directions. The next one is TE, and this one only goes in the z direction, the negative z direction. And so the negative TE is the only value we're going to have. The others are 0. And so I just rewrote it right here to make it a little bit more organized. The next step is to sum all the forces to equal 0. So you look right here at the sum of forces in the x direction. So we have -6/7 times TB, -6/7 times TC, and then we have TD. So I wrote TD minus 6/7 TC minus 6/7 TB equals 0. That's our first equation. Some of the forces in the y direction, you see we have, these are 0, so we have 3/7 TB minus 2/7 TC equals 0 right here. And in the z direction, I wrote minus TE plus 2/7 TB plus 3/7 TC equals 0. The TE, I wrote right here for the second free body diagram. Since we only have some of the forces in the y direction, so right here, so we have TE, if you look up here, minus W. These are the only two forces we have. So you can put TE equals W, and we have that the weight of the block is 150 pounds. So we have TE already, and so I plugged that in here and just moved it over to the other side of the equals sign. So we have 2/7 TB plus 3/7 TC equals 150. And that's our third equation. We have 3 equations because we have 3 unknown variables we need to solve for. So that's the final step, is to just solve. So we have the first equation I used because it's just a cleaner equation. So I solved for TB. I got it by itself. I added 2/7 TC and multiplied it by 7/3 to give us 0.6666 TC. The next step I did was I took this value for TB and plugged it into this equation, equation 3. So we have 2/7 times, plugged in TB right here. So 2/7 times 0.6666 TC plus 3/7 TC. So now we have just TC in this equation equals 150. Simplified that and solved for TC equals 242 newtons. So that will help us to get TB. We can go back to this equation and plug the value for TC in right here, and it gives us TB equals 162 newtons. Now we have TB and TC, and so we can go to this first equation right here, and we have TD minus 6.7 TC minus 6.7 TB equals 0. Well, we know TC and TB, so we're just solving to get TD. So I got both of these to this side, added them to this side. So it's TD equals 6/7 TC plus 6/7 TB. And then you just plug in the values you got for TB and TC to here, add it up, and it gives you TD equals 346. And we already had the tension of E, this one right here, is just the weight. And so now we have the tension of all 4 ropes. Thanks.